All righty. You guys all see a whiteboard, right?
Yes, sir.
Wow, look at that, Fogarty in the 21st century. Yeah, there we go. Berger, you like that?
Sir.
All right, you guys know that what you did last week with Miss Delmage was you were talking about derivatives, right? And last week, all right, we're gonna let in Clark, right? Last week, you found the derivative of a function using what we call the limit definition, right? Can you all hear me?
Yes, sir.
All righty. So now remember what a derivative is. A derivative is simply the instantaneous slope at a point on a function. So for example, if f of x equals x squared, we know that that's a parabola. And if we go to different points on the x-axis, the slope at any particular point on that parabola will be different depending on where you are. Now, if we find f prime of x, now I know that that's going to be 2x, right? It's possible that you knew it was going to be 2x, but let's say you didn't know it was going to be 2x, right? What you learned last week was you learned that f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x, all of that over h, all right? So then all I would have to do is take that function right there and substitute it in. So f prime of x would be the limit as h approaches 0 of x plus h squared. Actually, let me do that in red, right? X plus h squared minus x squared, all of that over h. And you've done this often enough now. Hold on, I forgot to start recording, I think.
It's recording.
Oh, is it recording? Thank you, man. So if you do this here, fellas, if you do that binomial times binomial, you know that's going to be x squared plus 2xh plus h squared minus x squared, all of that over h. Now, you know that the negative x squared and the positive x squared, you know that you're going to cancel everything that doesn't have an h in it if you did it correctly, right? So we end up down here with 2xh plus h squared, all of that over h. Then I factor out the h's in the numerator. I can then cancel out the two h's. And then I end up with 2x plus h, but we know h, we can sub it as a 0, and we end up with f prime of x equals 2x, which is what we said at the beginning. So that's what you learned last week. Now, that's really not that big a deal, but it's a lot of work. But depending on how much practice you did with these, you might have figured out that your derivative for f of x equals x squared, you might have already figured out that f prime of x would have been 2x. Now, I don't know if you did or not, but what we're going to do today is we're going to introduce to you some rules finding derivatives where you might not have to do a whole pile of this work, because you have the rules that are at your disposal, right? So does that make sense what we're going to try to do?
Yes.
All righty. So the first rule I want to talk about is this rule called the power rule. All right. And the problem we just did is an example of an application of the power rule. So this we know without having to do any work. And you'll know how to do that in a second, right? So if you looked at your original function and then looked at the derivative, basically what do you notice? You notice that the exponent is going to come out to the front, and then the new exponent is going to be the original exponent minus 1. So our power rule is really easy. If you have a function, f of x, which is x to some power n, as long as n is any number but 0, right, the derivative of that function is going to be n times x to the n minus 1. So when we take what we had a second ago, f of x equals x squared, all we got to do is take 2, move it to the front. We get 2x, and then 2 minus 1, right, is 1, and we don't write 1. Does that make sense to you guys? Hello?
Yes, sir.
Sir.
All righty. That's not a big deal, I don't think. Now, somebody tell me why n can't be 0.
Because you can't, if it's
Well, if
x
you
to the
have
power of
x
0,
to
then
the
it's
0, what would you have?
1.
Yeah, so like that's why you can't have, that's why n can't be, it can be any other number. It could be a decimal, it could be a, negative number, it could be any number, it just can't be 0, all right? Does that make sense? So let's just use that rule for a few seconds, all right? So let's do an easy one. F of x equals x to the third. Well, we know what the rule is, right? F prime of x, we're going to take the 3 and we're going to move it out front. And then the new exponent is going to be 3 minus 1, and that's going to be 2. Make sense? It's kind of easy, isn't it? Sounds like it's too easy, right? Max, you look like it's way too easy for you. All righty, try this one. Let's do f of x equals x to the negative 50. All right, well, I can use the power rule, and then all I'm going to do is what? I'm going to move the negative 50 out front. So I'm going to get negative 50x, and then I'm just going to subtract 1. Now you got to be really careful with the negatives. So you see, sometimes people see, they see a 50 and a minus 1, they go 49. What's a negative 50 minus 1?
Negative 51.
51.
Yeah, so just be very careful with that, right? Does that make sense to you guys?
Yes, sir.
Yes.
Do yourself a favor. Try this one yourself, right? All right, try this one yourself. F of x equals x to the 3.5. What would f prime of x be? You guys get that right?
Yes, sir.
Sir.
Yeah, you take the exponent, move it to the front, you got 3.5 x, and then your new exponent is going to be similarly what you had, minus 1, 3.5 minus 1. Does that make sense, guys?
Yes.
Sir.
All right, so we're all clear on that, right? So
Yes, sir.
that's your first rule, and that's called the power rule. Now, sometimes it ain't written so easy for us. So for example, I can use this function, f of x equals 1 over x. Now, I want to use the power rule, and I can use the power rule, but not on how that is written. So what do I have to do with that?
Get the x out of the denominator.
Yeah, get the x out of the denominator. So f of x equals 1 over x is really what? F of x,
Negative x.
negative
X to the
x,
negative 1.
x to the negative 1. Very good. Does that make sense? See, that's x to the 1, right? So like if you move it up, you just make the exponent negative, right? Or the opposite. So there's my function. I had to rewrite it so that it was in the proper form. That's sort of like taking a fraction and making it a decimal, right? Well, what would f prime of x be? Well, now the rules are really simple. What do I do with that negative 1?
Move it out front.
So I get negative 1 times x, right? That's times, right? Right? And then what's a negative 1 minus 1?
Negative.
2.
Negative 2. So I don't really write negative 1. I just write negative x to the negative 2. Does that make sense?
Sir.
Yeah, so sometimes what you got to do is you got to rewrite the function to get it in the form that you want. So let's try another one, right? F of x equals the cube root of x. All righty, well, now we know we're going to rewrite it. So what does f of x actually become? How do you rewrite the cube root with a fractional exponent? Anybody remember?
X to the 1/3.
Yeah, very good. X to the 1/3. Hold on one second. Now, once we have a rule though, fellas, what's the nice part about math? There's no exceptions. Spell two. T-O-O, T-O, T-W-O. Which one is it? I don't know. But in math, there's no rules. Now I can use my power rule. There's no exceptions, right? Where do I move the 1/3?
Up front.
Yeah, so I got 1/3 times x to the, well, what's 1/3 minus 1? Well, what's 1 with 3 as a denominator?
3 over 3.
Yeah, 3 over 3. So what's 1 minus 3?
2.
Huh?
Negative.
Negative 2/3, right? Does that make sense? So what I end up with is f prime of x is 1/3 x to the negative 2/3. Does that make sense to you guys?
Yes, sir.
All righty. Try this one on your own, Chiefs. F of x is equal to the cube root of x squared. Tell me what f prime of x is. All right, off you go. Made a mistake. Did you guys get that?
Yes, sir.
Yes, sir.
Not too bad, right? No, that's a lot easier than doing, that's a lot easier than doing the limit definition all the time, isn't it?
Sir.
All righty, not a big deal, right? Comprende? Comprende?
Yes, sir.
See.
So there's the first rule we learned today, power rule. If we have a function, f of x, x to the n, and n does not equal 0, then f prime of x is simply n to the x, n times x to the n minus 1. No big deal, right? All righty. Second rule, nice and easy. Constant rule. What's constant mean? If I say constant, what's that mean?
Unchanging.
Yeah, it doesn't
number.
change.
It means a number. All righty? So now pay attention. Here's what the constant rule says. If you have a function, f of x, that's equal to some constant a, then the derivative, f prime of x, is 0. All right. That makes perfect sense. Ready? Watch. What it says is if you have a function equal to a constant, the derivative has to be 0, right? So I'm going to draw the graph. I'm going to draw the graph of f of x equals 2. Fellas, that's f of x equals 2, yes?
Yes.
Good. Whatever point you went to on that line, what would be the slope? So like if I go to this point here, x is -2, and I drew the tangent line, what would it be?
0.
Yeah, the slope would be 0. If I went all the way out here and I found the instantaneous slope, it's a horizontal line. So your instantaneous slope has to be 0. So anytime you have a function where you have a horizontal line, when's that? When it's a constant. The derivative is just 0. Does that make sense? Hello?
Sir.
So if I told you f of x equals 5, what's f prime of x?
0.
0.
If I told you f of x equals -4, what's f prime of x?
0.
0.
If I told you f of x equals 1024, what's f prime of x?
0.
0.
0. Beautiful. That's pretty easy, right?
Yes, sir.
You sure this is an honors class?
Sir.
Hey, Murphy's in it. Oh, all righty. So now we got the power rule and we got the constant rule. Now I'm going to give you the multiplier. Hey, fellas, all the problems we did with the, if we went back, if you looked at your notes and you went back and you did the power rule, what was the coefficient of x in all of those problems to start?
1.
Yeah, 1. So here's what the multiplier rule is for. The multiplier rule is what do you do when you have something that looks like the power rule, but you have a different coefficient? All right. What do you think, Murph? Do you think the rules change?
No.
What do you think you do at the end?
You multiply to the A.
Yeah, you just move it out front. And then what do? Subtract 1 from the end. And then there you go. So just like for example, if you did this, x to the 5th, and I said, what's f prime of x? Well, what would you do? You would take the 5, move it out front. What's 5 times 1? 5. And then what's 5 minus 1? 4.
4.
Agreed? All right, so let's just change it up a little bit. F of x equals 2x to the 5th. All right, so f prime of x, I'm just going to take the 5 and move it out here. What's 5 times 2?
10.
And then what's 5 minus 1?
4.
4.
Done. That's not too bad, right? And just got to be careful of signs and stuff like that. And just don't make mistakes when don't be rushing and trying to get things done really, really quickly. So if I go g of x equals negative 3x cubed, what do you think g prime of x is? Well, let's just follow our rules. I'm going to take my little exponent, move it out here, and I'm going to get 3 times negative 3 times x to the 3 minus 1. So 3 times negative 3 is negative 9, and then 3 minus 1 is 2. So I got negative 9x squared. Does that make sense? Try this one on your own. F of x equals 2x to the negative 3rd. What's f prime of x? Work that out for yourself. You all get that right? How many people put negative 3 for the exponent? Anybody? Nobody made that mistake? Very good. All righty. So there's your third rule. So we did the power rule. We did the constant rule. We did the multiplier rule. And now I'm going to give you the sum difference rule. All right? So this is the power rule, we're good. Constant rule, we're good. Multiplier rule, we're good. Now, here's the nice part about this, the sum difference rule. All right, the sum difference rule, you don't have to learn anything new. Ready? Here's what it says. Ready? If you have a function, f of x, and that function is made up of, let's say, g of x, and then we're going to go either plus or minus another function, h of x. Well, all this rule says is f prime of x equals g prime of x, either plus or minus h prime of x. Now, what does that mean to you? Well, what that means is if you have a polynomial and you're asked to give me the derivative of the polynomial, all you got to do is find the derivative of each little term. That's it. All righty? So let's see what that looks like. All right? So it looks really complicated, but it's really not. So I'm telling you that f of x equals x to the third plus x to the negative 4. Well, according to what I just told you, ready? F prime of x would then simply be whatever the derivative of f prime of x to the third, right? It would simply be find the derivative, let me do the same colors, find the derivative of x to the third, and then add to it the derivative of x to the negative 4th. So for both of these, you're just going to use the power rule. So f prime of x. All right. Take the 3, bring it out front. 3x, what is that? 3 minus 1?
2.
Squared. Now let's go over here. Take the negative 4, bring it plus a negative means what? Minus, right? 4x, and then what's negative 4 minus 1? Negative 5. So this expression is the derivative of that expression. All you do is take your polynomial and find the derivative of each term. All you got to do is use the rules you know. Guess what you don't have to do? You don't have to use the limit definition. All righty? Let's try another one. So I gave you something that looks like this. All right? F of x equals 2x to the third minus 7x squared plus 3x minus 100. All righty. Not a big deal. It would be a big deal if you had to use the limit definition. Can you imagine putting that into the limit definition? Holy mackerel. So let's just find the derivative of each term. So let's just take this one first. What's the derivative of that? Go.
6x squared.
All righty. Now let's take the derivative of that.
Negative 14x.
And now let's find the derivative of this. Yes? Yep.
It's 3x.
Yeah, because like, look, if you move the 1 out, 3 times 1 is 3. What's 1 minus 0? 1 minus 1 is 0. What's x to the 0?
1.
And then finally, gents, what's that?
0.
0.
Yeah, we never write the 0. So here's what we know. F prime of x would simply be 6x squared minus 14x plus 3. Can you imagine using the limit definition on that?
I'll try not to.
All righty. I'll give you one you can work on your own. Ready? F of x equals x to the 5th plus 2x to the 3rd minus x squared. That's what f of x is. Tell me what f prime of x is. Are you all good?
Yeah.
That makes sense, right?
Yep.
So now what would you do if I said this? what is the derivative of this function, right, at 2, at x is 2? So what am I asking you? When x is 2, what is the instantaneous slope of that function? So all you would do is what?
Plug it in.
Into.
Wherever you see x, put
2.
2. All righty. So 2 to the 4th is 16, right? What's 2 squared?
4.
All righty. All right. 5 times 16, 80. 6 times 4, 24. Minus 4. All right. So we got 80 plus 24 is 104. Minus 4, 100. So the instantaneous slope of this picture at x equals 2 is going to be like that. It's going to be really, really steep and really, really positive, right? But that should have made sense. Like, look at that. You got x to the 5th, right? Does that make sense to you guys?
Yes,
All
sir.
right. Now I'm going to try to trick you. Ready? F of x equals 2 over x to the 3rd minus 1 over x squared. What's f prime of x? Use everything you've learned so far, right? Anybody finish yet?
Sir.
Is that what you got?
Yes, sir.
Beautiful. Now, tell me what then, if this is what you got, tell me what this is. Is that what you guys got? Did you guys do that properly?
Yes, sir.
Sure.
Everybody understand it? No, now notice what I did, fellas. How many people just worked it out with this and didn't do that? All right. The better you are at your algebra, the easier this all becomes. All right. So far today, so far today, all right? So we know, based on what you've learned so far, that if you're trying to find a derivative, the first thing you learned how to do was use the limit definition. And the limit definition is just using slope formula, right? And then today, we made things a little easier for ourselves. We introduced the power rule. We introduced the constant rule. We introduced the multiplier rule. And then we introduced the sum difference rule, right? And what all of these rules do for us is they make it really easy to find the derivative of polynomials. Does that make sense?
Yes, sir.
All righty. So the last thing we got to do today is I'm going to just give you 2 rules that you need to memorize, right? And it's the last rule. And we're going to do trig functions, right? How do you find the derivative of trig functions? But the only 2 we're going to worry about this year are sine and cosine, okay? And all you got to do is memorize these for now. We're not going to prove them or anything like that. There'll be plenty of time for that next year. Ready? So here's what we got. If f of x equals the sine of x, the derivative, or f prime of that, would be simply the cosine of x. All right? Does that make sense?
Yes, sir.
Second one. If f of x equals the cosine of x, then the derivative, or f prime of x, is the negative sine of x. And then next year, what you'll do is you'll look at that on, like they'll graph the sine and the cosine function, and then you'll see why this has to be true, okay? But for now, all you got to do is remember the derivative of the sine of x is simply the cosine of x. The derivative of the cosine of x is the negative sine of x, all right? So, for example, f of x equals 7 sine of x plus 3 cosine of x. Okay? Let me not screw that up, right? Well, all we're going to do to find the derivative what did we say the sine of x? What's the derivative of the sine of x?
Cosine of x.
Cosine of x. And what did we say the derivative of the cosine of x is?
Negative sine of x.
Now, when you simplify that, what would you actually do here?
Make it -3.
Yeah, positive times a negative. What do you get?
Negative.
That becomes a negative, right? Negative, and then you can get rid of that, right? Negative sine of x. All right? Does that make sense? That you just have to memorize, and then you can use it for yourself. All right? So let me give you a couple of those. Let's work on a couple of those. It's just a matter of learning how to use it. Ready? First one. F of x equals 5x squared plus 4 times the sine of x. If that's f of x, what would f prime of x be? What are we going to use in this first thing here? What rule are we going to use here?
Multiplier rule.
Yep. So what do we get?
10x.
10x. Very good. And then over here, what are we going to use? The trig rule, right? What are we going to get?
4 cosine.
Cosine.
4 cosine of x. Good. Does that make sense, guys?
Sir.
Hello? All right. Try this one. F of x equals negative 5x squared minus 4 times the cosine of x. What would f prime of x be? It's almost the same problem, not quite. What are we going to use there?
Multiplier.
Yep, we got negative 10x, right? And then what are we going to use here?
Trig rule.
All right, now you got to be careful. What is this? What does this become?
Plus 4 sine x.
Negative sine of x, and a negative times a negative is a positive. Very good. Makes sense, right, guys?
Sir.
Sir.
All right. I guarantee you, Burger, I'm going to get you on this one.
Okay.
Burger, you're going to get this one wrong.
Sure.
All right. How many people think Burger's going to get it wrong? Nobody? Wow.
Y'all believe in me, sir.
They're all fools. All right, Burger. F of x equals 8 times the sine of x minus x. What's f prime of x? Watch out, Burger. Eric, what do you got here? Eric, what do you got there?
8 cosine of x. I forgot I was on
Thank
mute.
you very much. 8 cosine of x. Now, this is where you can make a mistake. How many people put minus x? Nobody? Burger, what you put?
Nothing, because I don't know. Would it
What?
just
All
be
right, now pay attention. Come on, Eric. Ready? Watch. What's the exponent here?
1
Where does it go?
up front?
All right, so minus 1. What's 1 minus 1?
0.
What's x to the 0?
1.
1. What's 1 times 1?
1.
There you go. See how that works? Whenever you get confused in math, the one thing that you can remember about math is it's probably math and science, right? And not so much, I don't know. At least they're still capable of understanding that there's a truth to math. When it comes to theology and philosophy and everything like that, everything's opinion, right? There's no opinion in math. So when you see something and you get a little confused, right? So I see negative x. So in my class yesterday, they all told me it was x. It was 8 cosine of x minus x, right? All you have to do is follow the rules, right? This is a 1. So you take the 1 and move it out front. And then you're left with 1 minus 1, which is x to the 0. Anything to the 0 power is 1. So you got 1 times 1. 1. Make sense?
Sir.
Burger, you got it wrong, Burger. Oh. All righty. One more, and then we'll be done for the day. All right? Here we go. F of x equals 9 times the cosine of x minus 7x squared. So, somebody tell me what f prime of x is.
Negative 9 sine of x minus 14x.
Negative 9 sine of x. Beautiful. And then over here, I'm just going to move that out. Minus 14. Then 2 minus 1 is 1. X. Beautiful. All righty. Does that make sense to you guys?
Sir.
Yes, sir.
All righty. Now pay attention. Here's what I want you to do for your homework, right? And your homework, this isn't a long, this is just practicing using these rules. So it's actually kind of fun. Page 772, do 1 to 15 odd. And then all you have to do is write the derivative, right? Don't worry about what the directions say. Just write the derivative of each function, right? So all it is exactly what we've been doing. All you're doing is practicing. Just do it on a sheet of paper, take a picture of it, and email it to me. That's all. Comprende?
Sure.
All right. Anybody have any problems? Anybody have any questions? Hey, fellas, look how easy it is to find derivatives using those rules. It was important to learn the limit definition so you actually knew what it is you were doing when you find a derivative. All right? You're using a limit. You're trying to make the limit as close to 0 as possible so that you get an instantaneous slope. All righty? You all good with that?
Sir.
Anybody else have any questions?
No, sir.
All righty. You're good to go if you want. All right? I got office hours at 2 if you need anything.
Thank you, sir.
Everybody's family still good?
Sure.
All righty, babes.
Sure.
Have a good one.
You too, sir.
Thank you.
Right.
And all
Thank
the
you,
best.
sir.
Coach
All the
Fogarty.
best.
Coach Fogarty.
Yes.
Me and Evan were gonna try and make
Hold
it.
on. I got to stop recording this.